What if the universe has already sent us a warning? Beyond the pale light of the stars lies an ocean of silence. Interstellar space, a place where fragments of dead suns drift for eons, carrying the memory of worlds long extinguished. In that darkness, unseen by human eyes, wanderers are born, fragments that do not belong to any star yet travel between them like forgotten messages adrift in a cosmic sea. In 2024, astronomers detected such a traveler, a faint, silent intruder slipping into the dominion of our own sun. They named it 3I Atlas. It is the third known interstellar object to cross our skies, a shard from somewhere beyond, neither invited nor fully understood. To science, it is a data point. To imagination, it is a question carved into the void itself. Think of it as a messenger, a relic from a world we will never see, a line torn from a book that has burned away, leaving only this single fragment in our hands. We study its trajectory, its brightness, its faint whispers of dust and ice, but the story behind it remains locked in silence. And yet, there is tension here. Could such an object bring not only wonder but peril? Could it stir the orbits of worlds? Could it strike or scatter fragments that one day cross Earth's path? The question lingers like a shadow across the night sky. Is 3I Atlas merely a harmless wanderer from beyond, or does it carry with it the possibility of a worst-case scenario for our fragile civilization? It began with a faint signal on the edge of the sky. Not a flare of brilliance, not a comet blazing a trail across the night, only a dim flicker against the canvas of stars, caught by instruments designed to watch the heavens for danger. In January of 2020, the Asteroid Terrestrial Impact Last Alert System, known as Atlas, was sweeping the skies. Its purpose was not discovery for discovery's sake. It was built as a sentinel to guard Earth against the silent threat of near-Earth objects, fragments of rock and ice that drift close enough to strike. Its telescopes in Hawaii scanned night after night, cataloging the unremarkable and the familiar. On that night, however, Atlas found something different. The system recorded an object moving against the background stars, faint but steady. At first glance, it looked like just another small body of ice and dust. A new comet, perhaps, destined to loop around the sun like so many before it. It was given the temporary designation C2020M3, later refined to 3I Atlas. But then the calculations began. Astronomers from Atlas and Pan-STARRS, another sky survey based in Hawaii, compared its motion to known patterns. Comets and asteroids in our solar system travel along predictable orbits, tied to the sun's gravity like stones on invisible strings. This one did not. Its velocity was higher than expected. Far higher. It was moving faster than the sun could hold. Instead of curving into a bound orbit, its path stretched outward like an open hand, unmistakably hyperbolic. Its eccentricity, the measure of how stretched an orbit is, was greater than 1, a mathematical signature of an interstellar visitor. That was the moment of revelation. This was no ordinary comet. This was an intruder, a fragment that had crossed the gulf between stars, slipping silently into our solar system's domain. The news spread quickly through the scientific community. Memories of 2 earlier interstellar visitors stirred. ʻOumuamua in 2017, with its mysterious elongated shape and tumbling light curve, and Borisov in 2019, a true comet from beyond. And now a third, 3I Atlas. Early data suggested a body just a few kilometers wide, icy, fragile, shedding faint dust as it passed through sunlight. It was dim, easily lost in the glare of stars, and would remain visible only for a brief season. Yet even in its faintness, it carried a weight that could not be ignored. For the astronomers who traced its path, the realization was profound. They were watching not just a comet, but a messenger from another system older than memory, born around a star whose light may never touch Earth. At the University of Hawaii's Institute for Astronomy, and in observatories scattered across the globe, scientists turned their instruments toward it. Every measurement mattered. Its brightness told of the ice it carried. Its speed told of the journey it had made. Its orbit whispered of a home beyond the sun's dominion, somewhere in the crowded arms of the Milky Way. It was faint. It was fleeting. But it was real. And for the third time in human history, we were witnessing a visitor from the stars. The discovery of 3I Atlas did not bring silence. It brought shock. Astronomers had already tasted the improbable. In 2017, ʻOumuamua appeared, the first interstellar object ever confirmed. It was a visitor unlike anything seen before, its elongated form tumbling through sunlight, reflecting light in ways no comet or asteroid had. Its trajectory was clear. It came from beyond, moving too swiftly to be bound by the sun. But ʻOumuamua carried more than mystery. It carried controversy. Its path showed a tiny but undeniable acceleration, as though pushed by an invisible hand. No jets of gas were seen, no obvious cometary tail. Scientists debated whether sublimating ice could produce such a force or whether something else was at play. To this day, it remains an open question. Then in 2019 came Borisov. This second interstellar visitor was a relief in a way. It behaved more like a comet. A long, hazy tail stretched behind it, streaming dust and gas as it neared the sun. Its composition resembled comets from our own solar system, though with hints of more volatile ices, perhaps shaped by the environment of another star. Borisov was strange, but it was at least familiar. A cosmic wanderer that looked like what it was, a comet. By 2020, astronomers believed these sightings would remain rare. Interstellar objects were expected to be scattered thinly across the galaxy, faint and fleeting, almost impossible to detect. The chance of seeing two within just a few years had already seemed extraordinary. To witness a third so soon was nothing short of shocking. Atlas entered with its own peculiarities. It came with an unusual orbital inclination, slicing across the plane of the solar system like a blade at an angle, as though it had been hurled from some tilted, forgotten corner of the galaxy. Its velocity was astonishing, more than 30 kilometers per second relative to the sun. At that speed, it was unstoppable, a stone skipping across the gravitational field of our star, never to return. At first, its appearance seemed comet-like. It glowed faintly, a halo of dust surrounding an icy nucleus, but almost immediately there was instability. Observers reported fragmentation. The nucleus itself seemed to be breaking apart, shedding pieces as it journeyed through sunlight. By the time telescopes fixed their gaze, it was already dissolving, as though it could not withstand the passage through our system. This duality unsettled astronomers. On one hand, it behaved like a comet, fragile and volatile. On the other, its path was undeniably interstellar. A paradox in motion, a body both familiar and alien. The comparisons began at once. How different it was from ʻOumuamua. Where the first was elongated, dry, and strangely accelerated, Atlas was unstable, fragmenting into clouds of dust. Where Borisov was long-lived and steady, Atlas was ephemeral, fading almost as soon as it appeared. In less than a season, it would be gone, leaving only orbital data and fractured memories. But it was not only the differences that sparked shock. It was the pattern. 3 interstellar visitors, one after another, within only a handful of years. The universe had gone from silence to a chorus. Astronomers asked themselves what this meant. Was it coincidence born of better instruments? The Atlas survey and pan-stars had indeed revolutionized sky watching, scanning wide swaths of the heavens night after night. Perhaps these wanderers had always passed by, invisible to earlier generations. Now, with new eyes, we were finally able to see them. Or was there something deeper? Was the frequency of these visitors increasing? Was the solar system crossing a denser stream of interstellar debris, fragments cast out by distant stellar nurseries, shaped by collisions around alien suns? If so, what did it mean for Earth, a small world orbiting quietly within this cosmic current? The thought carried unease. For millions of years, humanity lived without knowledge of interstellar objects. Now, in just a few short years, 3 had appeared. The question lingered in scientific journals and quiet conversations alike. Why now? Some argued that statistics explained it. The detection rate, they said, had simply caught up with reality. Thousands, perhaps millions of such fragments may pass through the solar system every year, most too faint to detect. ʻOumuamua and Borisov were only the first of many more to be revealed as technology advanced. 3I Atlas was evidence that the era of discovery had only begun. But for others, the pattern felt uncanny. Each object was not only interstellar but unique, defying easy categorization. ʻOumuamua's acceleration, Borisov's composition, Atlas's fragmentation, all different, all unexpected. If they were common, why did each bring a new mystery? The scientific shock was not only in numbers but in nature. These visitors refused to fit the neat boxes of classification. They were neither simply asteroids nor simply comets. They were reminders that the galaxy is more chaotic, more diverse than the small sample of objects orbiting our sun. At conferences, astronomers spoke with reverence and unease. The realization was sobering. The solar system is not an isolated island. It is open, vulnerable, and connected to a wider galactic stream. Objects from beyond can and do enter. They can pass close, scatter fragments, or even strike. In geological time, such impacts may already have occurred, shaping Earth's history in ways we cannot yet trace. The shock was both intellectual and existential. To witness 3 interstellar objects so quickly was to confront the scale of the cosmos anew. Each fragment carried within it the possibility of answers to ancient questions. What minerals form around alien stars? What chemistry blooms in the dark between systems? Could life itself be seeded by such travelers? And yet with each answer came new shadows. If these objects carried dangers, they would arrive unannounced. Earth, a fragile cradle of civilization, might one day face not a local asteroid, but an interstellar missile hurled unknowingly across the stars. The thought lingered, haunting the edge of every calculation. So the shock of 3I Atlas was not just in its discovery, it was in the recognition of a truth that could not be ignored. The universe was no longer a distant backdrop. It was crossing into our lives, casting fragments of its hidden history through our skies. Why now? Why here? And why so many in such a short time? These questions remain unanswered. But with each interstellar object, the cosmos seems to whisper louder. Humanity listens, torn between wonder and unease, knowing that the sky is not only a source of light but also of shadows. The first glimpse of 3I Atlas was only the beginning. A faint signature on a sky survey meant little without deeper study. To understand what this fragment from beyond truly was, astronomers needed more than a trail of motion. They needed light. Every photon that touched Atlas carried a story. The sun's rays, reflected from dust and ice, traveled millions of kilometers before reaching Earth. Collected by telescopes, dispersed into spectra, they became fingerprints. Within those faint lines of color, scientists searched for chemistry. Did this traveler carry the familiar signatures of water ice, carbon compounds, or volatile gases? Or would it reveal something alien, born in a nursery far different from our own? The earliest analyses sought the glow of a cometary tail. Borisov had trailed gas and dust, a visible declaration of its icy nature. ʻOumuamua had shown none, leaving questions that still echo through astronomy. Atlas seemed at first to lean toward the cometary side. A halo of dust surrounded its nucleus, though weak and inconsistent. Through spectroscopy, observers detected faint hints of cyanogen and diatomic carbon. Gas is often released when sunlight warms frozen materials. The chemical voice of Atlas whispered, but faintly, yet something unusual appeared alongside this whisper. The nucleus did not remain stable. Over weeks of observations, its brightness fluctuated, not in steady rhythm but in sudden changes. Some nights it was brighter, others dimmer, as though breaking apart in silence. High-resolution imaging suggested multiple fragments, shards drifting away from the parent body. The fragile visitor was dissolving before our eyes. This behavior troubled astronomers. Typical comets fragment occasionally, but 3I Atlas seemed more fragile, more unstable than most. Was it a remnant from a system whose comets formed differently, less tightly bound? Or had it endured an unimaginable history, close passes to other stars, collisions in alien realms, that left it weakened by the time it reached us? The brightness variations were mapped carefully. Scientists asked whether the changes came from tumbling, as with ʻOumuamua, or from disintegration. The data leaned toward fragmentation. Unlike ʻOumuamua's peculiar light curve, which suggested a cigar or pancake-like shape rotating through space, Atlas appeared to be shattering. Its story was not one of endurance, but of impermanence. Spectroscopy deepened the picture. The gases detected matched some of those in long-period comets of our solar system, but with subtle differences. The abundance ratios hinted at a slightly different chemical environment, as though forged in a colder, more volatile, rich region than most of our local comets. If true, Atlas may have formed far from its parent star. in the frozen outskirts of a system where exotic ices could condense. Yet the anomalies kept emerging. Some measurements showed weaker gas emissions than expected given its brightness. This suggested that much of its glow came not from fresh gas but from dust reflecting sunlight. A dusty, fragile body, shedding more solid particles than vapor, unlike many comets seen before. The comparisons continued. To long-period comets from the Oort cloud, Atlas bore resemblance, icy, fragile, easily broken. Yet its velocity betrayed it. No solar-born comet could move so swiftly, its hyperbolic path immune to capture. The similarities ended at chemistry. Its soul was foreign, the challenge was time. Interstellar visitors do not linger. Their speeds carry them quickly through the solar system, giving only months for study before distance dims them into invisibility. ʻOumuamua had escaped within weeks. Borisov gave a longer season but was gone within a year. Atlas, fragmenting as it was, proved even less forgiving. By the time instruments turned with precision, its brightest days were already fading. Teams across the world scrambled. Observatories in Hawaii, Chile, the Canary Islands, and beyond pointed their mirrors at the fragile wanderer. Each night mattered. Each spectrum, each brightness curve, each image added to the mosaic. But the visitor slipped steadily away, crossing deeper into the outer solar system, retreating into silence. The frustration was palpable. In the fragments of light gathered, much was revealed, but much was lost. If only more time. If only more clarity. Atlas would never pass again. Its path carried it back to the galactic deep, to vanish from sight forever. And yet within those fleeting months, humanity had glimpsed something extraordinary. A body that spoke both in familiar and unfamiliar tones. Water like ice, yes, but fragile to an unusual degree. Dust, yes, but more abundant than expected. Chemistry aligned with comets, yet tilted just enough to suggest an alien cradle. The deeper investigation left no neat conclusions. Atlas was a paradox straddling categories, neither fully like Borisov, nor like ʻOumuamua. It was its own story, a reminder that interstellar objects are not uniform but diverse. Each one is a chapter torn from a different book, written in a different stellar nursery, each carrying hints of worlds unseen. The fading of Atlas carried a weight of melancholy. For astronomers, to lose sight of an interstellar visitor is to close a door that will never reopen. The universe had offered a fragment and then taken it away. What remained were numbers, spectra, and images, fragile attempts to preserve the fleeting presence of a traveler from beyond. The challenge of study underscored a larger truth. Humanity is still unprepared for these visitors. Our instruments are powerful, but they react rather than anticipate. Objects like Atlas arrive without warning, demanding swift attention, then vanish into the dark. The window for discovery is narrow, the opportunity fragile. If we are to truly understand them, new systems will be needed. Faster response telescopes, dedicated spectroscopic surveys, even missions designed to intercept. But in 2020 with Atlas there was only the present moment, a fragile comet-like body, shattering as it passed, whispering secrets of a star system we will never see. Its deeper investigation revealed not answers but mysteries layered in dust and gas. And as it faded from view, the question lingered in silence. If even fragments can cross between stars, what else might journey with them? What stories of chemistry, of formation, of life itself, might be carried in such fragile messengers? For now only light could speak, and the light of Three-Eye Atlas was already slipping away. The story of Three-Eye Atlas did not end with discovery. It unraveled. Unlike ʻOumuamua, which survived its swift solar passage and escaped intact, and unlike Borisov, which endured long enough to show its true cometary nature, Atlas broke apart before reaching its closest point to the sun. It crumbled under the very light that revealed it, scattering into fragments and dust before its secrets could be fully known. This disintegration carried with it a haunting paradox. For millions, perhaps billions of years, Atlas had survived the emptiness of interstellar space. It had drifted through the radiation of distant stars, endured encounters with cosmic rays, and traversed the dark gulfs between suns. Yet only now, in the warmth of our star, did it fail. Why did it endure the extremes of interstellar exile, only to crumble at the threshold of our solar system? The question unsettled astronomers. Was it that the sun's heat was simply too much for its fragile bonds? Or had its structure already been weakened by a history we could never see? Collisions, stresses, tidal forces, so that the final act of disintegration was inevitable. The shattering of Atlas raised more than scientific questions. It raised existential ones. For when a body fragments, its trajectory changes. Each piece carries momentum, slightly altered by the violence of its breakup. The original path may have been harmless, but fragments spread unpredictably. Could one be nudged onto a collision course with Earth? The odds were low, vanishingly small, yet not zero, and it is in that narrow space between the possible and the impossible that human imagination dwells. Astronomers ran simulations calculating the spread of fragments, mapping the probability cones. No impact was expected, but the realization lingered. An interstellar object could fragment in just such a way, and the consequences would be beyond comprehension. The thought deepened unease. These objects do not belong to us. They are not part of the predictable ballet of our planets and comets. They come from unknown nurseries with unknown chemistries. Their compositions are guesses, reconstructed from fading spectra and brief encounters with light. What might they carry hidden in their dust? For decades, scientists have debated panspermia, the idea that life or its building blocks might travel between stars, carried on comets and asteroids. Could interstellar objects be couriers of organics, seeding the galaxy with chemistry that one day blooms into biology? The idea is speculative, yet not impossible. Amino acids, the precursors of proteins, have been found in meteorites on Earth. Complex carbon molecules drift through interstellar clouds. Chemistry is not bound by borders. It crosses space just as Atlas did, but speculation cuts both ways. If such bodies can deliver the seeds of life, could they not also carry unknown dangers? Pathogens alien to Earth? Exotic molecules that disrupt biology or chemistries incompatible with our fragile ecosystems? No evidence exists for such threats, yet the possibility itself haunts the imagination. To receive a fragment from another world may be a gift or a catastrophe. In laboratories and observatories, scientists debated not only the nature of Atlas but the broader pattern. Why now, within just a handful of years, had 3 interstellar objects passed close enough to be seen? ʻOumuamua in 2017, Borisov in 2019, Atlas in 2020. For generations, no such objects were known. Now they appeared in sequence as though heralding a new age. Some pointed to technology. The sky surveys of the 21st century, automated and relentless, were finally sweeping with precision across the heavens. Atlas Pan-STARRS, the Zwicky Transient Facility, all had revolutionized our ability to see faint moving points of light. Perhaps these wanderers had always been there, unobserved, but others whispered of timing. Could the solar system be drifting through a denser region of interstellar debris? Could nearby stellar nurseries, collisions or disruptions in the galactic plane be sending a current of fragments across our path? If so, the 3 known visitors were not anomalies but harbingers of many more to come. The sense of escalation was unavoidable. ʻOumuamua had been a mystery of motion and shape, Borisov a mystery of composition, Atlas a mystery of fragility and destruction. Each had unsettled, each had brought more questions than answers, and each had come swiftly after the last. Astronomers found themselves confronting a new reality. The sky above was not a closed system. It was open to the galaxy, porous, alive with fragments from alien histories. The boundaries between here and out there were dissolving. Humanity was not alone in its cosmic neighborhood. It was part of a stream exposed to the drift of other stars, and so the unease grew. If 3 had come so quickly, how many more would follow? Could the next be larger, more dangerous? Could one arrive not as a faint comet, but as a massive body on a path toward collision? The probabilities remain small. Earth's long history bears few scars from interstellar impacts, yet the very possibility forces reflection. Civilization depends on predictability, on the assurance that the cosmos follows patterns we can measure, understand, and prepare for. Interstellar objects fracture that comfort. They arrive unannounced, unfamiliar, and unpredictable. In the fading dust of Atlas, the mystery deepened. It was not only a question of what these visitors are, but of what they mean. To science, they are opportunities, windows into other systems, samples delivered across impossible distances. To philosophy, they are reminders that humanity's story is not isolated, but woven into a greater galactic fabric. To imagination, they are omens. Whether of creation or destruction, no one can yet say. The escalation is not in the objects alone. It is in us. in the way they force us to question the safety of our skies, in the way they blur the boundary between science and speculation, between hope and unease. Atlas dissolved into fragments before it could complete its journey. Yet in its destruction it left behind something enduring, a question: how many more are coming? When 3I Atlas slipped into the solar system, its arrival reignited a question as old as astronomy itself. Where do such wanderers come from, and what stories do they carry across the void? The leading models point to chaos in alien star systems. During the birth of planets, countless fragments are scattered. Some are captured into stable orbits, forming belts of asteroids and comets. Others are ejected, flung outward by the gravitational slingshots of giant planets, cast adrift into the galaxy. In this picture, ʻOumuamua, Borisov, and Atlas are the flotsam of other worlds expelled long ago, destined to wander between suns. Each fragment is a relic of a planetary nursery that may look very much like our own, or perhaps utterly unlike it. But beyond this conventional view lie more exotic possibilities. What if interstellar objects are not merely comets and asteroids? What if they are the ruins of worlds, a planet shattered by impact, its pieces hurled into interstellar exile, a moon torn apart by tidal forces, scattering fragments across the stars, or, even more haunting, the exposed cores of failed worlds, iron and rock stripped bare, wandering as silent testaments to destruction. In this vision, Atlas is not just ice and dust. It is the grave mark of a world that once was. Some go further still. Might such objects even be artifacts? The idea seems radical, yet it was openly debated after ʻOumuamua's strange acceleration. Could an object that behaves unlike any comet be artificial? Perhaps a fragment of technology from another civilization? Mainstream science leans toward natural explanations, outgassing of invisible ices, exotic but plausible shapes. Yet the speculation lingers at the edges, for interstellar objects by their very nature belong to realms we cannot yet reach. They are emissaries from unknown histories. Even in their natural form, they may carry significance beyond the physical. Some scientists revisit the ancient theory of panspermia, the notion that life is not confined to one world, but spreads across the cosmos through fragments of rock and ice. Meteorites have delivered amino acids to Earth, complex organic molecules shaped in the cold dark of space. If such chemistry is common, then interstellar objects could be the seeds of life itself. A comet from a distant star might one day fall upon a barren world, delivering the raw ingredients from which biology can bloom. In this sense, Atlas could be both visitor and gardener, a courier of possibility. But speculation also conjures darker visions. Could such messengers bring not seeds but poisons? Molecules alien to Earth, destabilizing to fragile ecosystems. Even hypothetical pathogens born under conditions we cannot imagine, carried unknowingly into new environments. There is no evidence for such dangers, yet in the shadows of possibility, unease grows. The same fragment that could sow life might just as easily sow destruction. Some thinkers push these ideas further, into the territory of cosmological worst cases. What if interstellar objects are not simply icy relics, but carriers of forces far beyond our comprehension? Could one deliver destabilizing isotopes altering planetary environments? Could they carry dense clumps of dark matter, invisible yet destructive if they were to intersect with Earth's orbit? And there are theories still more haunting. Physicists have speculated about the fragility of the universe itself. Our cosmos, they say, may exist in a false vacuum state, a precarious energy configuration that could collapse if disturbed. A passing fragment carrying the wrong interaction might in theory trigger such a collapse, rewriting the laws of physics in an instant. It is speculative, bordering on the philosophical, yet it underscores a truth. In a universe governed by vast energies and delicate balances, even small things may carry unimaginable weight. The behavior of interstellar objects also highlights the unforgiving mathematics of motion. Einstein's relativity and the laws of orbital mechanics explain why they move as they do. Their speeds are immense, often tens of kilometers per second, far beyond what the sun's gravity can bind. Their orbits are hyperbolic, open curves that cut through the solar system once and never return. No planet, no star, no force within reach can capture them. They are the epitome of transience, reminders that not everything can be held. This very impermanence intensifies their mystery. Humanity can study them only in passing, As they flicker briefly in the night sky, then vanish forever, we are given fragments of data, incomplete spectra, fading trails. From these we build theories, knowing that certainty will always remain just out of reach. Amid these mysteries, the words of Stephen Hawking echo with renewed weight. He often warned of the dangers that may lie in the unknown, that humanity, curious yet fragile, must tread carefully when confronting forces from beyond. In his reflections, the cosmos was not hostile but indifferent. And in that indifference, danger resides. Interstellar objects embody this truth. They are not malevolent, yet they arrive unbidden, carrying with them possibilities we cannot yet measure. In Atlas, the universe presented both beauty and fear, a fragment that had crossed the unimaginable distances between stars, bearing chemistry and structure born under alien light, yet fragile enough to disintegrate before our eyes, scattering uncertainty across its path. It forced us to speculate, not just about what it was, but what it means. Each theory, whether grounded in planetary science, chemistry, or cosmology, reminds us of the vastness of possibility. Atlas might have been nothing more than ice and dust. Or it might have been a seed or a shard of destruction or something stranger still. In every case, it is a messenger. Not one that answers, but one that compels us to ask. And so, as Atlas fades into the abyss, it leaves behind a deeper awareness that the galaxy is not silent, that our solar system is not isolated, that fragments from alien histories cross our skies, carrying with them the weight of countless unknowns. They come unannounced. They vanish without return. And each one forces us to confront the same unsettling truth. The universe is larger, stranger, and more fragile than we dare to believe. The discovery of 3I Atlas forced a change in perspective. For centuries, humanity gazed at the night sky believing the solar system to be an island. Now, with 3 interstellar visitors revealed in just a handful of years, astronomers face a new reality. These objects are not rare accidents. They are recurring guests, crossing our skies with quiet persistence. And to understand them, new tools must rise. In the deserts of Chile, on a mountaintop in the Andes, a new sentinel prepares to open its eye. The Vera C. Rubin Observatory, with its vast 8.4-meter mirror and panoramic camera, is designed to sweep the heavens with unprecedented speed and depth. Beginning operations in the mid-2020s, it will capture the entire visible sky every few nights, cataloging billions of stars, galaxies, and small bodies. Among them will be interstellar wanderers. Simulations suggest that Rubin could detect hundreds of such objects over the coming decades. Where once a single sighting was extraordinary, tomorrow it may be routine. The significance of this shift is profound. No longer will scientists rely on chance encounters, on faint signatures slipping briefly across telescopes. Rubin will provide systematic discovery, building a census of interstellar debris. Their numbers, their trajectories, their diversity, all will be revealed. For the first time, humanity will glimpse not only solitary fragments, but the full scope of the galaxy's hidden traffic. Yet discovery is only the first step. To unlock their secrets, astronomers must study their light with instruments capable of dissecting it into its finest details. Here, the James Webb Space Telescope offers promise. With its infrared eyes, Webb can detect the faint heat signatures of distant objects, revealing ices and minerals invisible to optical surveys. It can measure spectra that betray the presence of carbon dioxide, water, methane, molecules that tell of chemistry forged under alien suns. Already, Webb has begun to reshape our understanding of exoplanets and distant galaxies. When pointed toward an interstellar visitor, it could reveal its innermost makeup. Other instruments add to this chorus. The Atacama Large Millimeter, Submillimeter Array, or ALMA, stretches across the Chilean plateau with dozens of radio dishes, tuned to the faint whispers of cold molecules. Comets in our solar system have been studied with ALMA, revealing jets of carbon monoxide and complex organics. An interstellar visitor, passing within range, could be mapped in molecular detail. What ices it carries, what chemistry it preserves, could become known with extraordinary precision. But ground-based observation and remote spectroscopy have limits. To truly know an interstellar fragment would require more. A mission, a probe to intercept, to fly alongside, to sample. Concepts already exist. ESA's Comet Interceptor mission, scheduled for launch later this decade, is designed to wait in space until a suitable target is found, then dash forward to meet it. Originally conceived for long-period comets, the mission could, with fortune, be redirected toward an interstellar visitor. Other proposals dream even bolder. Projects like Breakthrough Starshot have explored the idea of ultra-fast light-sail probes capable of reaching high speeds. Scaled down, such technology could intercept interstellar comets. Equipped with cameras, spectrometers, even dust collectors, they could send back direct data rather than fleeting spectra. What has so far been inferred in shadows could instead be seen in detail. Meanwhile, on Earth, simulations grow ever more sophisticated. With vast computing power and artificial intelligence, scientists model the probabilities of interstellar encounters. They trace the trajectories of ejected fragments from star-forming regions, watching as billions of simulated comets scatter into the galaxy. They predict which streams may intersect with our solar system and how often. These models suggest what the surveys may soon confirm. The galaxy is filled with such bodies, and the solar system is constantly brushing against their flow. Machine learning now aids in their detection. Vast sky surveys produce oceans of data, millions of moving points tracked against billions of stars. Algorithms trained to spot the subtle arcs of motion can sift through this chaos, isolating candidates for follow-up. Where once discovery depended on human eyes scanning photographic plates, now artificial intelligence listens to the rhythm of the sky, alert for the faintest whisper of an interstellar messenger. Together, these tools mark a turning point. Astronomy has shifted from surprise to anticipation. ʻOumuamua, Borisov, and Atlas were once seen as singular events, unlikely to be repeated in centuries. Now they are understood as the beginning of a pattern. Interstellar objects are not curiosities. They are a recurring phenomenon, woven into the structure of the galaxy. This realization reshapes how we view our place in the cosmos. For if fragments of other stars routinely enter our skies, then the boundaries of the solar system are not walls but doorways. The chemistry of other worlds drifts through our neighborhood. The dust of alien comets mingles, however briefly, with the dust of our own. In each visitor lies the potential to answer questions long held in silence. How common is water beyond our system? How do other stars forge their comets? What role might these travelers play in the broader cycle of life and matter across the galaxy? And yet, these tools are not only instruments of curiosity, they are instruments of vigilance. To detect hundreds of interstellar objects is to confront the small but real possibility that one might pose danger. To intercept one is not only to study, but to defend. The same telescopes that reveal beauty also stand watch against threat. In this dual role lies the essence of the next era. Astronomy no longer observes from a distance. It responds. It predicts. It prepares. Humanity is learning to see interstellar objects not as distant wonders, but as part of the dynamic environment in which it must survive. When Vera Rubin opens its eye, when Webb turns its mirrors, when ALMA tunes its dishes, when probes are launched to intercept, a new age of cosmic investigation will begin. An age when the galaxy's hidden fragments are no longer strangers, but subjects of study. An age when the silence between stars is broken not by accident, but by intent. And yet, beneath the precision of instruments and the rigor of models, mystery remains. No telescope, however vast, can yet tell us the stories these fragments truly hold. No spectrometer can reveal the worlds from which they came. No simulation can predict the secrets of chemistry carried across the stars. Each visitor will bring questions beyond the reach of preparation. But with new tools, humanity is no longer blind. It stands ready to listen more closely to the messages carried by interstellar messengers, ready to measure, to capture, to learn, ready to face not only wonder, but whatever truths drift silently toward us from the abyss. Atlas was fleeting, fragile, lost before its story could be fully told. But it has helped shape this readiness. It has transformed how we look outward. And in the wake of its disintegration, the stage is set for the next visitor. Whether that fragment brings clarity or deeper shadows, we will be watching. For the first time in history, humanity has seen alien messengers not as radio signals or distant glimmers, but as physical bodies. ʻOumuamua, Borisov, Atlas. Fragments of other stars have crossed into our skies, not imagined, not theoretical, but real. They remind us that the boundaries we once drew around the solar system were illusions. Earth has never been an island. It is a shore, and tides from the wider galaxy wash upon it. There is symbolism here that cannot be ignored. These objects arrive uninvited from forgotten stars, carrying the silent history of places we will never know. They come as guests, but not as allies. They are indifferent travelers. Their presence is not a message by intent, but a reminder of a truth that lies deeper than intention. The universe does not need to speak to us to remind us of its power. Its fragments do the speaking for it. With them comes fear. The fear of impact, the nightmare of a fragment large enough to shatter civilization. The fear of contamination, of alien molecules mingling with Earth's delicate biology. The fear of what might hide in dust unseen waiting to touch us. Yet beneath these lies a quieter, more enduring fear. The fear of perspective. The fear of realizing how small we are and how fragile. In every encounter with interstellar visitors, we are reminded that the cosmos is not built for us. It is vast, restless, and indifferent. It does not shelter. It does not protect, it allows. In that allowance, life can arise. In that same allowance, life can be erased. There is no hostility here, no guiding hand. Indifference is colder, sharper, more unsettling than malice. For malice can be answered. Indifference cannot. And so humanity stands at a threshold. For the first time, we do not imagine alien contact as a distant possibility. It has arrived already, not in signals or artifacts, but in shards of stone and ice, carriers of chemistry, of memory, of questions. They drift through our skies and vanish again, leaving us to wonder. The visitors are silent, yet in their silence they provoke. They ask us to measure our place not within a solar system, but within a galaxy alive with fragments and chance encounters. Perhaps the true worst-case scenario is not impact, nor contamination, nor even the collapse of certainty under strange physics. Perhaps the deepest unease lies in what these wanderers force us to confront, that we are a young species in a vast and restless cosmos, that our world is small, that our time is brief. Atlas disintegrated before its story could be told. It did not strike, did not seed, did not change the balance of Earth. And yet in its passing it accomplished something profound. It reminded us that the universe does not wait for us. It moves endlessly, scattering fragments of alien suns across the dark. Some reach us, most do not, but all whisper the same truth. We are not the center. We are not isolated. We are fragile creatures standing on the shore of an ocean that does not end. The tide is coming in, and it will come again. Perhaps the true danger of 3i Atlas is not what it carried within it, but what it revealed within us. The realization that the universe is not only vast but restless, and that our place within it is not secure but borrowed. So the question remains open and unanswered. What is the greater risk? That interstellar objects bring with them dangers we cannot foresee, or that they remind us of the truth we fear to face? That in an endless, indifferent universe, the worst-case scenario is not what comes from beyond, but the silence of knowing just how small we are.